At the end of the big sheet, we got a number which got transferred to another sheet. And so there we were a bunch of girls, and we were doing that. Which
all in a big room?
No, we were in little offices, 2 or 3 to an office.
Ulam's Monte Carlo calculation followed the fates of individual deuterium nuclei as the shockwave from an atomic explosion passed through them. He got his answer first. The deuterium would not ignite. The super would never work.
Famously, at one point, von Neumann said to Ulam with considerable disgust, icicles are forming, meaning this explosion wasn't getting hotter, it was getting colder. It was going the wrong way. This was his vision, this was his dream, this was the only idea, serious idea that he had at that point for how to make a hydrogen bomb. And remember, he had promised the United States government that if it invested vast sums of money, that there would be a hydrogen bomb, that he knew how to make one.
The results on the hand calculation were announced a little earlier. When they were announced, perhaps wrongly, I did not believe them. Within a few weeks, the machine calculations came in, and that I had to believe. I think it may have been just due to my prejudices, but I believe that the one was a method that could have been wrong, and the other one was a method where the probability of its being wrong was much smaller.
Because Johnny von Neumann had done the calculation?
No, because it was a computer.
But you know, by doing the calculation, by personally being the person who sat down and worked those numbers, Ulam, in a very deep psychological sense, had cleared away Teller's super. That idea was out. And he could then begin to think about other possibilities that perhaps hadn't been conceived at all. And in fact, was thinking about how you could get bigger yields from atomic bombs when he made the crucial breakthrough. Because truly, Stan Ulam was the father of the hydrogen bomb, not Edward Teller. Edward Teller, as one of his friends said, was perhaps the mother, since Stan rather impregnated him with this idea and then he developed it.
He told me, I had come home for lunch, and he was staring out of the window and told me, I think I found a way to make it work. So I was just coming home for lunch, I didn't know what he was talking about. And I said, what work? And he said, the super. And I became I wondered what really is going to happen. I was very happy that the super couldn't be built, and this horrible super weapon was not feasible, and that finally we had found a. And he said, well, it'll change the world.
So what exactly was Stan Ulam's idea? Well, it's still secret, so it's impossible to tell for sure. But I think it's a fairly good bet that it was something rather like this. This is how you make an ellipse. Now, this shape has some extraordinary properties. If you imagine it in 3 dimensions and silvered on the inside, so there's this sort of mirror, and you were to shine a light at one focus, then all that light would converge at the other focus. And if you built this 3-dimensional ellipse incredibly robustly, and you set off an explosion here at one focus, then the debris from the explosion would converge in an implosion at the other focus. Now, this is an incredibly simple mathematical idea, and it's taught to people at secondary school. If this was Stan Ulam's idea, well, it contains with it two of the important ideas that were to make the H-bomb possible. Firstly, the idea of separating the atomic bomb trigger physically from the hydrogen bomb. And secondly, the idea of using an atomic bomb to create an implosion to set off the hydrogen bomb. And if so, it makes a lot of sense that the idea occurred to a mathematician.
He hadn't been getting along very well with Teller when he was doing those calculations. Teller didn't like the results. So I said, "What are you going to do about it?" And he said, "Well, I'll have to go talk to Edward."
Ulam came to me with a suggestion which was not new, but which was a little related to these things. I told him this won't work, but if you change it a little in this way, then it will.
The H-bomb was to work something like this. An atomic bomb at one end emits X-rays which initiate a violent implosion in a separated secondary stage. This sets off a mass of deuterium, which in turn ignites a jacket of uranium-238. The explosion of the first test bomb, Mike, took place on the island of Aluga Lab in the Pacific. After the explosion, the island was found to have disappeared.
So here we are. That this is a full-size replica.
This is a full-size replica of the hydrogen bomb.
Exactly. This is exactly the size of each one of the 10 warheads in an MX missile.
And now you've worked out how it works.
Exactly. When the U.S. government in 1979 tried to block publication of my story on this, they said that I had correctly identified the three key elements of the Teller-Ulam idea.
Suppose this was actually going off now. What happens to all these buildings around? Would any of them be left standing?
Right now, you and I would be history. Probably right under us would be a hole the size of a large soccer stadium or football stadium. And every building you see within a mile and a half would be knocked flat to the ground. Beyond that would be a firestorm. It would be a mushroom cloud filled with the radioactive debris of all this stuff that's been pulverized, and probably lethal radioactive fallout would extend at least 50 to 100 miles downwind.
And how many people would be killed?
Easily a third of the people on Manhattan Island by this
Millions.
one explosion. Millions.
It had been the mind of a human being, and not the computer, that had found the solution to the problem. But the last laugh, as usual, went to Johnny von Neumann, because the computer turned out to have applications far beyond the nuclear weapons program. It really did change the world.